For most mammals, birth is a relatively straightforward physical event. A foal or a calf is often standing within minutes of a delivery that was brief and physically uncomplicated. Human birth, by contrast, is a unique biological outlier, characterized by its duration and its extreme physical difficulty. The difficulty begins with how our ancestors moved. When we transitioned to walking upright, our skeletal structure had to change to support our weight on two legs. This forced the pelvis to narrow and become more compact to provide a stable base for bipedalism. As our hips narrowed, our brain size increased, creating a conflict, a large infant skull attempting to move straight through a narrowed pelvic opening. Looking at the specific dimensions, in a straight-line descent, the head is physically wider than the birth canal. To bypass this physical impossibility, the human birth canal evolved as a curved, asymmetrical tunnel. It is a passage where the available space is constantly changing shape from the entrance to the exit. Because of these tight tolerances, a human birth requires a specific, dynamic sequence of physical shifts. Every millimeter of movement is dictated by the precise geometry of the bones. This process is driven by a chemical feedback loop. When labor begins, the mother's brain releases oxytocin, which triggers uterine contractions. These initial contractions then signal the mother's brain to release even more oxytocin, creating a continuous cycle of force. These contractions serve two distinct mechanical roles. They pull the cervix open, a process called effacement and dilation, while simultaneously pushing the fetus deeper into the pelvis. This top-down view shows the pelvic inlet, an oval opening widest from side to side. To fit through, the fetus must face sideways, aligning the longest part of its head with that horizontal width. As the fetus is driven lower, it encounters the muscular floor of the pelvis. The resistance of these muscles forces the baby to tuck its chin tightly against its chest, a movement known as flexion. This profile shows the result of that tuck. By changing the angle of the head, the fetus presents its smallest possible circumference to the birth canal, reducing its physical footprint. This initial phase of labor is a process of extreme physical compression, where the fetus is forced to minimize its dimensions to clear the first anatomical bottleneck. Lower down in the mid-pelvis, the geometry of the canal shifts. The space is no longer widest from side to side, it inverts, becoming widest from front to back. To clear this section, the fetus physically corkscrews 90 degrees, aligning with the new vertical orientation. During crowning, the head catches underneath the pubic bone, acting as a pivot to swing upward in an arc and emerge. Even with the head delivered, one final hurdle remains. The baby's broad shoulders are positioned horizontally, but the exit is widest vertically. To clear this, the emerged head turns 90 degrees back to the side, aligning the internal shoulders with the vertical exit. All these movements are not random. They are a specific sequence required to navigate the changing physical terrain of the human birth canal. Once the shoulders are clear, the resistance vanishes. The rest of the infant's body follows easily, ending the mechanical phase of birth. This transition triggers an immediate biological change. The sudden exposure to air prompts the infant's first breath, which forcefully expands the lungs for the first time in its life. This first breath creates a sudden change in pressure that physically slams shut the foramen ovale, a specialized valve in the heart. This closure instantly reroutes the infant's entire circulatory system to the lungs. Simultaneously, the mother's system is flooded with a massive surge of oxytocin and endorphins, triggered by the conclusion of the physical labor. This chemical surge serves two immediate functions. It initiates the bonding process between mother and child and stimulates the final contractions needed to deliver the placenta. From the first rotation of the skull to the internal reconfiguration of the heart, human birth is a process of total coordination. It is a sequence where every physical movement and chemical signal is required to successfully transition from one environment to the next.